This is question number 1 in the non-calculator section. We're asked to evaluate, which just means work out, and we have a complicated looking fraction which has other fractions within. In order to do this one properly, we are going to consider the numerator in its entirety, because all of that has to be divided by the denominator, which is 2/9. So we'll write it out not as a fraction but as a division with a division symbol. So that's 1/4 take away 1/6, and we're to divide all of that by 2/9. We'll look at the bracket first. We have 1/4 take away 1/6. In order to subtract, we need the denominators to be the same. So if we multiply this one by 3 on the bottom, and then obviously we have to do the same on the top, that will give us a denominator of 12, and multiplying the other one by 2 will give us the same. So that will then give us 3/12 take away 2/12, and we want to divide all of that by 2/9. So 3/12 take away 2/12 is 1/12, and we want to divide by 2/9. So now we have a division with two fractions to do. We never actually do a division. Anytime we have a division with fractions, we always change it to a multiplication. So we're going to have 1/12, and we're going to multiply. But the rule is, when we change from divide to multiply, we flip the second fraction upside down. So to multiply two fractions, we don't need the denominators to be the same. We simply do the top times the top and the bottom times the bottom. So 1 times 9 is 9, and 12 times 2 is 24. We can simplify this. The number 3 goes into 9 and into 24. 3 goes into 9 3 times, and 3 goes into 24 8 times. So that gives us 3/8, which is the final answer to the first question. This is question number 2 in the non-calculator. We're asked to expand and collect the like terms, and we have double brackets, and we have a square bracket, and these are adding together. So move this over to give us a bit more space. So the first thing we're going to do is multiply the double brackets. That means we want to multiply everything from the first bracket by everything in the second bracket. So we'll take the 4x first of all, and we'll multiply that by the second bracket, and then we will take the -2 from the first bracket, and once more multiply that by the second bracket. Then we have our plus sign, and then we have our squared bracket. So when something is squared, it just means we are multiplying by itself. So 4x times 2x gives us 8x squared. Then we have 4x times 3, which is 12x. Moving on to the second bracket, -2 times 2x is -4x. And then the -2 times 3 is -6. Now again, we want to multiply double brackets here. So we want to multiply x by the second bracket, and then -1 by the second bracket. So we'll write that down. X times the second bracket, and -1 times our second bracket. So we have 8x squared, and then over here we have a couple of like terms which we can simplify at this stage. 12x take away 4x, which gives us 8x, and then we have our -6. Now moving on here to the second part where we're multiplying these brackets out, we have x times x, which is x squared. Then x times -1 is -x. Then -1 times x, -x again. And then we have -1 times -1, so two negatives multiply to give us a positive, and that's 1. Once again, we are looking to simplify, which means we're looking for like terms. So we have 8x squared, and then we have plus x squared. So that gives us 9x squared. and then we have positive 8x, and then negative x and negative another x, so that then gives us plus 6x, and finally we have negative 6 and we have positive 1, which gives us negative 5. So we have our final answer now, 9x squared plus 6x, take away 5. It's fully simplified, so that's our answer. This is question number 3 in the non-calculator. We're told a camera is on sale at 34% less than its recommended retail price, and we're told that this sale price is £99. We're then asked what the original recommended retail price was. This is an example of a reversing the percentage change question. So our camera is currently on sale at 66% of its original value. That's 100% take away the 34%, and that sale price is £99. As far as these questions go, this one might not immediately seem the most obvious, but if we look at the numbers 66 and 99, then we should realise that 33 will go into both of those. So if we divide 66 by 33, and we divide 99 by 33, then we get on this side 2%, and on this side we get £3. Now we have a percentage, 2%, which we can easily multiply to go back to 100%. So we need to multiply by 50, and again we need to multiply by the same amount on the other side. So 50 times 2% gives us our 100% original retail price, and 3 times 50 gives us the original value, which is £150. That's and the final answer to the question. Question 4, we're asked to factorise fully. So we should remember that means we want to put the brackets back in. Part A, we have 10h plus 12h squared. This is a highest common factor question. So looking at the numbers first of all, the biggest number that goes into 10 and into 12 is 2. And then if we look at letters, we can see an h appearing in both terms. So we can take that outside along with the 2. Put the brackets in, get the plus sign in the middle. So we need 2h times something to give us 10h, so that's 2h times 5. And then 2h times something to give us 12h squared, so that would be 6h. We've taken out our highest common factor and fully factorised our question. That's our answer. Question 4b, the second of the factorised questions. So remember, it says factorise fully. So if we look at this one here, we can see straight away, hopefully, there is a common factor of 8. So we can take 8 outside the bracket, leaving us with 1 minus u squared inside. So taking it the highest common factor in part A, that was enough to finish the question. But the word in the question says factorise fully, and we should spot here that we also have a difference of 2 squares in here. So we have 1 minus u squared, which isn't quite a difference of 2 squares yet, but 1 can be written as 1 squared, which now gives us our difference of 2 squares. So that gives us 8, and then we get our double brackets, one with the plus sign, one with the minus sign, and then we have 1 and u and 1 and u in both. So we have now factorised fully, and that's our final answer. This is the third of our factorised questions in number 4. We have d squared minus 3d minus 10. We should recognise this one as a trinomial, so those factorise into double brackets. We normally set our working out at the side with one bracket set above the other one. So starting at the front, first of all, d squared. We look for two things to multiply to give us d squared, which is obviously d and d. Then we move from the front to the end, the number 10. So we're looking for two numbers that multiply to give us 10, but bearing in mind that they somehow need to combine by adding or subtracting to give us the number 3. So the two numbers we'll choose 2 and 5. We could of course have chosen 1 times 10. So crossover, and d times 5 gives us 5d, and d times 2 gives us 2d, and that has to be equal to the thing in the middle, which is negative 3d. So the sign is important. So we want to put a sign on the 5 and the 2 so that we get negative 3d. So that would be negative 5 and plus 2. So d times 5 has to give us negative 5d, which tells us that the 5 is negative, and the d times 2 has to give us the plus 2d, which tells us positive. So we have d plus 2 and d take away 5. That's our final answer for question 4c. This is question number 5 in the non-calculator. It's obviously a surds question. We're asked to add and subtract the surds, so we can't do that until they're the same. So we'll do that by simplifying them first. So we have 4 root 75. So 75 has to be 25 times 3 plus root 27, which is going to be 9 times 3. Take away 2, and then we have root 147, which is going to be 49 times 3. So we'll then split them into separate roots. So we have 4, and then root 25, root 3, plus root 9, root 3, take away 2, root 49, root 3. So that then gives us 4 times the square root of 25, which is 5, root 3, plus the square root of 9, which is 3, root 3, take away 2 times the square root of 49, which is 7, root 3. So move this up a little bit, give us a bit more space. So we have 4 times 5, which is 20, root 3, plus 3, root 3, take away, and then it's 2 times 7, which is 14, root 3. So 20 root 3's plus another 3 root 3's is 23 root 3's. And then if we take away 14 root 3's, then that leaves us with 9 root 3's. So that will be our final answer, 9 root 3. Question number 6 in the non-calculator. We're asked to rationalise the denominator, which basically just means get rid of the square root on the denominator. So the denominator is this part down here, so we want to get rid of the root 10. So in order to do that, we're going to multiply by root 10 on the bottom. That will make the root disappear. So that means we'll need to multiply by root 10 at the top as well. So we're effectively just multiplying by 1, which means we're not changing the value of our fraction, we're just changing how it looks. So on the top we have root 5 times root 10, which will give us root 50. And on the bottom we have 10, first of all, and we're going to multiply that by, we have root 10 times another root 10, which simply gives us 10. So we now have root 50 over 10 times 10, so that's 25 times 2, if we're going to simplify that. And then 10 times 10 is 100. Let's move that up a bit to give us more space. Splitting the root on the top into separate roots, root 25 and root 2 over 100. The square root of 25 is 5, so that's 5, root 2 over 100. We can then simplify. 5 goes into 5 once, and 5 goes into 120 times. So that leaves us with 1 root 2 on the top, which is just root 2, and then 20 on the bottom. So our answer is root 2 over 20. This is question number 7 in the non-calculator. Part A, the first of 2 equations to solve. So we have 3x plus, and then 2 times a bracket, then plus 5, and that's equal to 4x. So the first thing we're going to do is get rid of that bracket. So we have 3x plus, and then it's 2 times x, which is 2x. Take away 2 times 1, which is 2. Then we have a plus 5, and then equals 4x. So looking for like terms, we have 3x plus 2x, which is 5x. Then we have negative 2 add 5, which is plus 3, and that's equal to 4x. Our next step is to gather the letters onto the left-hand side and the numbers onto the right-hand side. So we're going to bring the 4x over onto the left-hand side of the equals sign, and move this plus 3 onto the right-hand side of the equals sign. So we already have 5x over here, bringing the 4x over, and remember to change sign when we bring it over. So our positive 4x changes to negative 4x. Similarly, the positive 3 changes to negative 3 when we take that over. So we have 5x take away 4x, which is x, equals negative 3. We don't have anything else to do. We now have our answer. That's the solution, x equals negative 3. 7 part B is the second of our equations to solve. Once again, we're going to start by multiplying out the bracket. So 7 times a is 7a. Take away 7 times 1, which is 7. Then we have take away 3a plus 5 equals 2 plus 2a. So we're going to gather the letters to the left and the numbers to the right, as in the previous question. But this time, before we do that, we're going to simplify. So we have 7a take away 3a and negative 7 plus 5. So 7a take away 3a is 4a. And then negative 7 add 5 is negative 2. So that's equal to 2 plus 2a. We're going to move the negative 2 onto the right hand side, and we're going to move the plus 2a onto the left hand side. So we have 4a here already. Bringing the positive 2a over gives us negative 2a equals. And on the right hand side we already have the number 2, and taking the negative 2 over, it changes to plus 2. So we have 4a take away 2a, which is 2a, and on the other side we have 2 plus 2, which equals 4. So we now have the 2 to take to the other side. 2 is currently multiplying that a, which means when it goes to the other side it will divide the 4. So we have a equals 4 divided by the 2, and 4 divided by 2 is simply 2. So we have a equals 2, which is the solution. Question number 8 in the non-calculator. We're asked to simplify, leaving your answer with positive indices. So we have a fraction. The first thing that we're going to do is look at the numerator. So we have 4a multiplied by 3a to the power of minus 5. So first of all, the 4 times the 3 part gives us 12. Then we have a to the power of 1. It's not shown, but the power is 1. Multiplied by a to the power of negative 5. So when we multiply, we add the indices. So just to make this really clear, I'll show the working for this at the side. We have a power of 1, add the negative 5. So we have 1 and a plus and a minus together gives us a takeaway. So we have 1 takeaway 5, which gives us negative 4. So that means that the power on the a is negative 4. So next thing we want to do is divide that by 6a to the power negative 2. So when we are dividing, we subtract the indices. So first of all, we have our 12 divided by our 6, which is 2. In order to find the power on our a, we remember that because we're dividing, we're going to subtract the indices. So once again, I'll put this over at the side to make it very clear. We have negative 4 and we're subtracting negative 2. So when we subtract a negative, it means that it becomes a positive. So that's negative 4 add 2, which is negative 2. So the index on the a is negative 2. The question states that we need to leave our answer with positive indices. Just move this up a little bit. So to achieve that, we use one of the other rules of indices, and that means we're going to take the a back down onto the denominator, which automatically changes the power back to positive once again. So our answer is 2 over a squared. Our second indices question. So once again we want to simplify and leave the answer with a positive power or a positive index. So on the top line we have 3x, and that's all squared, divided by 12x to the power of 5. So considering the numerator first, we want to square everything in the bracket, so that's 3 squared, which is 9, and x squared, over, and we have 12x to the power of 5. So we can't divide 9 by 12, but what we can do is simplify here. So we have 3 goes into 9 3 times, and 3 goes into 12 4 times. So that leaves us with 3 on the numerator and 4 on the denominator. Our x ends up on the top. And once again, because we are dividing, we are going to subtract the indices. So that's 2 take away 5, which is negative 3. We want to leave our answer with a positive power. So once again, we're going to move the x term back onto the denominator. So that's 3 over 4x, and the power is now positive, which means it's cubed. So 3 over 4x cubed is the final answer. This is question number 9, and the first in the calculator section. A farmer buys a new tractor for £42,000. It then depreciates in value at a rate of 10% in each of its first 2 years, and then at a rate of 8% in each successive year. The question asks us, how long will it take the tractor to be worth less than £26,000? So we start with the initial value, which is £42,000. Now, if it's depreciating at 10% or falling in value at 10%, then that means that we are left with 90% of the value. 90% as a decimal is 0.9, and that happens in each of the first 2 years, so it's multiplied by 0.9 to the power of 2. So if we do that on our calculator, then we get a value of £34,020. So clearly it's not less than £26,000 yet. In subsequent years it depreciates a little bit more slowly at a rate of 8%. So that means that we are going to take the current value, 34,020, and we're going to multiply by, and this time it will be 0.92. We don't know how many years it's going to take to fall below £26,000. So we'll do that 1 year at a time. So the first time we do that, we get £31,000, or £31,298.40. So we'll then do that again, and we'll continue doing it until our value drops below £26,000. So the second time we do it, we get £28,794.53, rounding to the nearest penny. Then we'll do it again on our calculator, which then gives us £26,490.97. It looks like we might manage it on the next attempt. So once again, we'll multiply by 0.92, and this time we get £24,371.69. So our value has now dropped below £26,000. So it took 2 years to drop to 34,020, and then a subsequent 1, 2, 3, 4 years to drop below the £26,000 threshold. So in total, that's 6 years. So that's the answer to the question, and the end of number 9. Question number 10, we're asked to calculate the gradient of the line passing through each pair of points. It says simplify each fraction where possible. So the first part, part A, we're given the points A and B. So A is 4, 4 and B is negative 8, 10. So we'll just make this a little bit bigger. So to do this question, we're going to use the gradient formula, which is m equals y2 take away y1 divided by x2 take away x1. So our points up at the top, A is the first point, so this is the x value from the first point, and this is the y value, so that will make it x1 and y1 for the first point. And for the second point, this is our x value, and this one's our y value. Since it's the second point, that's x2 and y2. So taking these values and substituting into our formula, we have m equals, and it's y2, which is 10. We're taking away y1, which is 4. We're going to divide that by x2, which is negative 8, take away x1, which is 4. So we have 10 take away 4 on the numerator, which is 6, and negative 8 take away 4 on the denominator, which is negative 12. We'll just move this up a bit. So the whole answer is going to be negative, we know that. And we have 6 over 12, which will simplify. 6 goes into 6 once, 6 goes into 12 twice, so it's going to be negative 1 over 2, or negative a half. So the gradient of the first line is negative a half. We are then given another 2 points, so once again we'll write down our gradient formula. M equals y2 take away y1 divided by x2 take away x1. As before, x1 and y1 for the first point, and x2 and y2 for the second point. Substituting those into the formula, we have y2, which is negative 18, and we're going to take away y1, which is 14, and we're going to divide that by x2, which is 8, take away x1, which is negative 2. So we just need to be a little bit careful with this one, with the signs and so on. So on the numerator, negative 18 take away 14, which is negative 32. And on the denominator, we have take away a negative, which is a positive. So that's 8 plus 2, which is 10. So overall, our answer is negative. We have 32 over 10, which will simplify. So 2 goes into 32 16 times, and 2 goes into 10 5 times. So that gives us our answer, which is negative 16 over 5. This is question number 11 and the last one in the calculator section. The diagram below shows an ornamental garden. The garden is in the shape of a rectangle with a sector of a circle added at one end. The length of the garden is 35 metres and its breadth is 20 metres. Part A asks us to work out OB, the radius of the sector, and part B, which isn't shown on the page here, asks us to work out the perimeter of the garden, which is the total distance around the outside. So part A, the radius of the sector, that's this bit we're going to look at. So it's not immediately obvious how we'll do this question. So I think what we'll do first of all is make the diagram a little bit bigger so that we can see exactly what we're dealing with. So we're trying to find the length of OB, the radius, we'll mark that in green. The first important thing to spot here is that we can make this into a right angled triangle. So in this right angled triangle we know several things. We know that the angle in here will be 1/2 of 160 degrees, so it will be 80 degrees. We also know that the length from here to here will be 10 metres because it's half of the length of this side, which is 20 metres. So that gives us starting points, which we'll be able to use trigonometry, so Katoa, in order to work out the length of the green line, the radius. So again, we'll just create a bit more space by moving this over here. So the first thing I'm going to do is draw the triangle a bit bigger so we can see a little bit more detail. So our right angle is here. We know that this length is 10 meters. This is the radius, the length we're trying to find, and the angle in here is 80 degrees. So we can use SOHCAHTOA to find that. So we'll start by labelling the triangle. The longest side is the hypotenuse. The side opposite the angle is the opposite, and the other side is the adjacent. So we'll then write down SOHCAHTOA. Now the question is to find the radius, which is the hypotenuse. So I'll mark a question mark on the H's. We know that the opposite side is 10 metres, so we will tick the O's. And the other piece of information we have is that the angle is 80 degrees. So that means using a calculator we could work out sine 80, cos 80 or tan 80. Now the one that ends up with all three parts marked, this one here, that's the one that we're going to use. So the question mark's on the H, so we'll start off by writing the H down. We can see that the O is above the S, which suggests it's going to be a division. So it's going to be the opposite side divided by sine 80 degrees. So the hypotenuse is the radius, the opposite is 10, and we're going to divide that by sine 80. So once again, we will need our calculator. Corrected to two, or rather three significant figures, that will be 10.2 metres. Now that's our answer to part A. Part B of the question asked us to work out the perimeter of the garden. So we'll look back at the original question to see how this all fits in. So the perimeter of the garden is the distance round the outside, so we have 35 metres, and then 20 metres, then another 35, and then we have this arc of the circle sector at the end. So the straight edge parts, we already know those, it's just a case of working out the arc of this circle sector here. So I'm going to start by clearing some of the additional lines from the original diagram. We'll then make it clear exactly what it is that we're trying to find, which is this arc length here. The angle at the centre is 160 degrees. So we'll use our formula for the arc length. Arc length is equal to, and we know it's part of the circumference of the circle, so it's pi multiplied by the diameter multiplied by the angle at the centre, 160 degrees, divided by a full circle, which is 360 degrees. Now, we don't know the diameter, but what we worked out in part A was the radius of the sector, which was 10.2, which means that the diameter will be 20.4. So that's pi times 20.4 multiplied by 160 over 360 degrees. So again, we're going to use a calculator at this point, which gives us an answer of 28.5, again corrected to three significant figures, and once again that's in metres. So that's the arc length of the sector, which is at the end of the garden. We, however, are looking for the perimeter of the whole garden, which means we will need to add that to the breadth and the two other lengths. So that means we're going to add 20 and then 35 and another 35. So if we work that out, that then gives us the perimeter of the whole garden, which is 118.5 metres. That's our final answer and the end of the question.